Welcome. Today we'll be introducing multi-step equations. Now this is just the introduction. We will be moving into more complex multi-step equations later on, but for this session we will just be talking about the introduction steps. So I have a few examples here that are all what we call multi-step equations. And what makes a multi-step equation is it means we're solving for a variable, whether it be x, y, a, b, z, n, v, any variable, and we want a solution where it says x equals or y equals, or the variable we're solving for that's in our problem, we want to get a solution for. We want it to equal something. That's what makes it an equation, an equal sign. So in this, we're going to be dealing with multiple steps where we're going to be dealing with adding, subtracting, multiplying, dividing, any numerous sets of order of operations in order to solve for our variable. Now the whole aspect of multi-step equations is to keep the balance. So what I have here in the middle is this little scale. And the scale we have to think of as an equation. For example, we know 3 is equal to 3. And by saying this, our scale is perfectly balanced. There's 3 on one side, 3 on the other. If we think about this in terms of pounds, we have 3 pounds on the left, and 3 pounds is equal to 3 pounds. But if this side said 4, now we would expect this scale to start tipping down because the 4 is heavier than the 3. This is not equal. So what we're trying to do here is maintain our balance with our equations, because we're going to be moving values from one side of our equation to the other, but we have to maintain our balance. So we'll be using our inverse operations that we've learned. So let's get into this. With this first problem I have here on the top left, I have 2x minus 5 equals 5. And what I want to do is I have to recognize what variable am I solving for. In this case, I am solving for x. It's the only variable in the equation, thus it's the only thing I could possibly be solving for. I need to get it into a situation where it says x equals. But how can I possibly do that? Well, I need to move anything that is not x to the opposite side of this equal sign. Everything else needs to go over to the other side except for the x. It just needs to be x all alone on the other side of that equal sign. So how can we do that? Well, we use what I talked about earlier, inverse operations. And if we understand inverse operations, inverse means the opposite. So for example here, I have this negative 5. What is the opposite of negatives? Positives, right? The opposite of subtraction is adding. So if I want to maintain my balance of this equation, and I want to move this over to the other side, what I do is I use the inverse operation. The inverse operation of subtraction is adding. So I'm going to add 5 here. By doing so, this makes negative 5 plus 5 0. And it essentially removes the 5 from this side of the equation. But in order to maintain the balance of my equation, I can't just add 5 and remove it from this side. I have to move it over to this side as well. In doing so, I get 5 plus 5, which we know as 10. Now I just bring everything else down. The equal sign gets brought down. Negative 5 plus 5 we set as 0, so I don't need anything there. We can consider that as canceled out. That's the whole idea behind this. We want to remove it from one side of the equation. I can bring my 2x down, and I have 2x equals 10. Now I need to continue on to solve for x, because we do not have x just by itself just yet. I still have a 2 attached here. So I need to start isolating my variable. How can I possibly isolate or get x all by itself so that no numbers are attached? Well, what we have to look at is this is 2 times x. This is a multiplication operation occurring between these values. So the inverse, or the opposite of multiplication, is dividing. So what I'm going to do here, in order to remove my 2 from my x, is I'm going to divide by 2. And just like we did with adding the 5, we have to maintain our balance. So what I do to one side of my equal sign, I have to do to the other side. I have to do the values on the other side. So in this case, I have to divide 10 by 2 as well. In doing so, my 2 will go into my 2 on my left side one time, and that'll give me 1x. And if we recall, 1x is the same thing as x. So I've essentially isolated my variable. I have x equals now. 10 divided by 2 we should know as 5, and I have a solution. X equals 5. And I could always check that. I can go back to my original equation of 2x minus 5 and plug in my value for x this time. This is 2 times x, recall. So 2 times 5 minus 5 equals 5. And we can solve. 2 times 5 is 10, minus 5 is 5, and 10 minus 5 is in fact 5, and 5 does equal 5. So we have done this correctly. Now there's other methods of multi-step equations. As I said, it's not just dealing with adding, subtracting, or multiplication and division. We have to sometimes deal with an assortment of them together or in different arrays. For example, in this next problem here, I have x over 3 plus 2 equals 8. Now I have a fraction, I have addition that I have to deal with. So I have two different operations in this case than the last problem where I was dealing with multiplication and subtraction. So when we look at the situation of removing or isolating our value, our variable here, we want to isolate x. X is what we're solving for. So how can I possibly solve for x? Well, again, I need to remove anything on the same side as x. So I'm going to start with this positive 2 here. I can remove this positive 2 by using its inverse operation. The inverse or opposite of adding is subtraction. So I'll subtract 2. And again, I want to maintain that balance of the equation. So if I subtract 2 from one side, I must subtract 2 from the other as well. In doing so, 2 minus 2 is 0, so I can say those are canceled out. I'm left with just x over 3 over here. And on this side, 8 minus 2 we know is 6. Now I'm not finished yet. I need to still get x all by itself, x equals, and I still have this 3 here. It's actually being divided by 3. Well, if you recall our last problem, we said the inverse of multiplication is division, which means the inverse of division, which is happening here, would be multiplication. So I'm going to multiply both sides by a value. Now to isolate a fraction, to remove the denominator, so to speak, we multiply by the denominator. I can multiply by its reciprocal, 3 over 1, or in this case, just 3. And what I do to one side, I must do to the other as well. So I'm going to multiply both sides by my denominator of 3. These will cancel or equal to 1, and x over 1 is just x. And 6 times 3 will give me 18. So I have my solution, x is equal to 18. Again, we can check this. Plug 18 in for x. We're saying 18 over 3 plus 2 is equal to 8. 18 over 3 we can simplify to just 6. And this is plus 2 equals 8. And we know 6 plus 2 is 8. And we have a valid solution. Now over on the top right here, we're dealing with distribution. This is a form of multiplication, so we just need to follow those steps of our order of operations to simplify our equation first before we can start solving for x. Again, we're going for the same goal here. We want to isolate our variable and solve for it to where it says x equals. So let's start, like I said, with our distribution. Order of operations say parentheses. We can't do anything with x plus 7, so I move on exponents. There's nothing to do. Multiplication is next. That's distribution. 3 times x and 3 times 7 as well. Distribution tells us multiply every value on the outside by every value on the inside. I'll have 3x plus 21 equals 3, just bringing everything down, simplifying our solution. And I'm going to use some methods that we've already used in our previous examples here. We have a positive 21, and I want to start isolating this x here. So let's remove anything that is on the same side as x that is not x. So let's remove this 21. The inverse of it adding is subtracting. So I'm going to subtract 21. What I do from one side, I must do to the other. So these will cancel here because 21 minus 21 is 0. We're left with 3x equals 3 minus 21 is going to give me a negative 18. And just like we did in our first example, we have 3 times x. So this is going to be the inverse, which is dividing by 3. Those will cancel, and we'll divide this side by 3 to maintain our balance. And we'll get x is equal to negative 18 divided by 3, which is a negative 6. And we have our solution. Finally, this last problem we have is 9n minus 6 equals 5n plus 18. Recognize in this situation we have two variables existing. So the variable is still the same, where they're both an n value, which means we just need to combine our like terms. In this case, our n's can be combined, and our non-variable terms, such as negative 6 and 18, can be combined as well. So let's start with that process. We always want to combine anything that's on the same side of an equal sign together first. For example, if we can combine 9n and negative 6, we want to do that. But of course, these are not like terms, so I cannot combine those terms together. Same thing on this side, 5n plus 18 cannot be done, so I'm just going to have to start moving values to the other sides of the equation. I want to start isolating a variable, but in order to do that, I need to start combining my like terms first. So let's move this 6 over here with this 18. We're going to use our inverse property. This is a negative 6, so I'm going to add 6. What I do to one side, I do to the other. Negative 6 plus 6 cancels, and we have 9n equals 5n 18 plus 6 is going to give me a 24 positive. Now I need to combine my n values. This is a positive 5n, so I need to use the inverse property, which is subtraction. Subtract 5n, what I do from one side, I must do to the other. 9n and 5n can be combined because they're like terms, and I'll be left with my solution of 4n equals 24. Now obviously this isn't my absolute solution because n is still not by itself. In this case 4 times n, so I need to use the inverse of multiplication, which is going to be division. I'm going to divide both sides by 4 because what I do to one side I must do to the other side of the equal sign. And in doing so, our 4's cancel on the left. We're left with just n equals, and on the right, 24 divided by 4 will give me my solution of 6. And that is the introduction to multi-step equations.